Okay. So, dear Neha Kapoor, now it is your turn. You are from India, Indira Gandhi, Delhi Technical University for Women, and your presentation is a review of hybrid power plant based on solar and wind energy. Floor is yours. Please start. You have about 15 minutes, then questions and answers.
All right. Thank you so much. Um,
Welcome. A
all right.
pleasure.
So, good evening, everyone. Thank you so much for giving me this privilege to be present here among all of you. So, I am Neha Kataria Kapoor and I belong to India. So, I am pursuing my PhD right now. I am trying to research on the renewable energy and various renewable energy sources and their the potential of basically renewable energy in India and how we can overcome the issues that we face and we come across during our day-to-day life. So I would like to share my presentation with all of you here. Yes, so is my presentation visible to each one of you?
Yes, we can see it.
All right, thank you. So, starting with the presentation, um, I have written a paper on the review on solar wind hybrid renewable energy system at remote locations. So, to extend this work further, I have tried to identify the location as well, which lies in Haryana in India only. So that is a remote village. So there I am working forward to it, but during I when I submitted this, I just did the review of that particular location and the entire review of the whole of the country. So my
Would you please make a full presentation just at the bottom on the right side before you can make a full presentation because we see your slides on the left side. So if you
sorry,
go down and
sorry,
just
sir.
make it a full presentation, that would be okay. That's good. Thank you very much.
All right, sir. All right. Thanks for correcting. So, sir, my presentation will go like this. I'll be giving you the introduction and then the Indian energy statistics, overview of solar and wind power, then coming to the hybrid wind solar power system, design and development of hybrid energy models. Then I'll be doing the comparative study of the tools that are generally used for optimization of hybrid system, the limitations that people come across while using these hybrid systems, then the conclusion and some literature review and the references. Starting with the introduction part, uh, so the paper basically gives us an idea of the innovative field of hybrid energy. So what is hybrid energy basically? So when we talk of hybrid, we mean amalgamation of two or more sources of energy. So why we are amalgamating or why we are just not going with one source? So the main concern lies here is so renewable energy is not very we cannot just rely upon it, not very reliable, because there are many reasons and causes where there is like a drop or like generally people but don't prefer using it where they need some reliable source. So in case of hybrid renewable energy systems, we basically cut out this, like we try to enhance the potential of this source like renewable energy. So we are trying for hybridization of solar and wind here. So the main advantage that we have got is non-intermittent power. That is because power is something that we cannot expect any kind of. We should not get any kind of intermittency in between. Otherwise, like many things get hampered. Another factor that is that we get through after using the hybrid system is the grid performance. So overall grid performance is improved, and then we are trying to investigate the lineament of solar and wind energy in India. and the footing of hybrid solar wind energy, where the potential lies basically. For that, I haven't put the Indian energy statistics, and I've taken it from the IRENA. Source, the resource potential chronicle trends of solar wind energy system are also being investigated. So coming to renewable energy, all of the world globally, we are facing environmental threats due to this increasing like use of non-renewable source. Sorry, yes, non-renewable sources. So that's why we don't we want to switch from the fossil fuels, and therefore we are trying to go to renewable energy. Moreover, the power demand is increasing day by day due to drastic globalization, and therefore, we are trying to switch totally to renewable energy. So we are just trying to figure out whether we can be like it is a reliable source or not. So we're trying to expedite the adoption of increasing amount of low cost but intermittent renewable energy. For that, I have proposed a renewable, I'm trying to find the scope of the renewable energy. So power generated from renewable energy source is generally intermittent in nature and not available 24/7. And therefore, we require hybrid models. So hybrid models are better, they are more continuous, that the power we get is more continuous, then it is reliable, and it is eco-friendly and that cost effective also. Hybrid renewable energy have great potential to provide more reliable power supply compared to the system that are standalone. Like if we talk of only solar or only wind or only geothermal. So like the hybrid systems are always better. So because if I talk of solar and wind, so both are in contrast, like they are contrasting in nature. When we have wind, we don't have sun. When we have sun, we don't have wind. So that's a very good combination. And in India, we can find a great scope. The hybrid systems support the modular design that can mitigate problems associated with the use of individual sources. So that's why we are combining the systematic procedure. Indian energy statistics say something like this. India is ranked number 5 in the electricity generation, and the total installed capacity in India, including the central, state, and private sector, is 348.116 gigawatts as on 30th of June 2021. The RE capacity of India accounts for about 25.626% of the total installed capacity. So we have growth, like we have done a lot of growth since the last years. And if I talk of SPV, the solar photovoltaics, they have the maximum installed capacity of 42.336 gigawatt, followed by wind, that is 39.486, and small and hydro biogas are at 4.793 and 8.338 respectively in India. So by 2030, we are aiming to achieve 40% of the power from renewables. And India generally approximately is accounting to 6.65% of world's carbon emissions. And we are ranked fourth after China, which is 26.83%, US 14.36%, and EU 9.66%. Then let's have a look at the India's RE sector. So India's RE sector has done a lot of there has been a lot of improvement since years. Starting of the data from 2014 till 21, the installed RE capacity in gigawatts has been shown in this table in the form of tabular form, where the percentage share of renewable energy in total installed capacity is also being compared with the generation from RE sources, total generation from all the sources, and then percentage of RE in generation. So this is the statistics that we have come across since last few years, and we are looking forward to improve in the coming time as well. Like we are trying to shift. Then the state-wise wind potential in India has been also taken from the National Institute of Wind Energy only. So this is the latest statistics that we find here. There about the various states where wind potential is found good. So wind potential in 100 meter gigawatt and 120 meter gigawatts. So there it is given for 7 states, including Gujarat, Karnataka, Maharashtra, Andhra Pradesh, Tamil Nadu, Rajasthan, Madhya Pradesh. And some other states is also given, and the total number accounts for 302.25 gigawatt and 695.50 gigawatts respectively. Then this is the schematic of hybrid wind solar power system that we are trying to work on in physical form as well on site. So wind turbine and a PV module is being connected with the regulation and conversion unit, and there is a generator and the load is being given here, and there is a battery bank for excess of power to be stored. Then if I talk of the flow chart for design and planning of a hybrid renewable energy system, so what all steps do we require if we want to install one? So first we need to evaluate the meteorological conditions on the target site. Then we need to analyze the load demand of the proposed site. Then hybrid system configuration, that which configuration is best suited for the particular location, the remote site that we are finding out where the energy is not reaching 24/7. Then we develop the hybrid system model which we find good for the particular location, and then we have to perform simulation and optimization, and in the last, operational analysis of the resulting system is being done before launching it to the market. So this is how we can go about in basic for the design and planning of an HRES. So I have tried to do the literature survey of 41 papers, and all categories of enlisting the details and the respective reference numbers have been reported in the form of tables in the paper as well. And we are trying to summarize the literature on the state of art research based on hybrid power plants from multiple standpoints. So I've tried to compare the feasibility of different locations, and then I've tried to compare the optimization techniques that we used and the limitations that we find for hybrid solar wind system. So these are the references that the reference I have tried to refer and cite in my paper. So with the help of my guide, um, Mr. Rizwan from Delhi Technological University, Professor Rizwan and Professor Nidhi Goel from Indira Gandhi Delhi Technical University for Women. So I have been able to perform this research work, and I have given the literature review on the same, including these particular papers. So these are 41 reference papers that I have like referred for my paper, and my work is being done like in future I'm trying to extend my work further, and I have identified a site, and then we are trying to like prepare a model for the target site. So these are all the references, and so this was all about my paper that I tried to write. Thank you.
Thank you very much. Thank you. Um, yeah, I would like to see whether there are any questions to you in the chat. I cannot see any. Um, Congratulations. Thank you very much for your
Thank you so much.
presentation.
Thank you so much, sir. It was very nice to be a part of this WWEC conference, and I was waiting since long to present my paper.
That's very good. Thank you very much.
Thank you so
You
much,
have
sir.
you have a nice day.
Thank you.
Now I would like to ask our General Secretary, Stefan, is the next presentation video ready? Okay.
Yeah.
Then we continue with Toba Fatima. But
Yes, sir.
Tuba Fatima, welcome.
Thank you, sir.
And your presentation is not listed in the session. So would you please present yourself before
Sir,
you start? And
isn't
then
that-
you have 15 minutes. Yes. Now
So is my presentation visible?
yes, but make it a full presentation. That's good.
Okay.
Thank you very much. And
Thank
you
you, sir.
should, this is the simulation and modeling of a hybrid solar wind energy system for rural, remote, and hilly areas.
Yes, sir.
Okay, this is a study prepared under the supervision of Dr. Jami Hussein, who is one of our technical chairs in World Wind Energy Association.
Yes.
So, Tuba, it is your word, and you have 15 minutes to make your presentation.
Sure, sir.
Please.
Thank you. Thank you so
Proceed.
much, sir. First of all, good morning, good afternoon, and good evening to all the respected people present here. As we all can see, the topic of my presentation is case of a standalone 9 megawatt solar wind hybrid system simulation at Pavagada, Karnataka, which is in India. These are the papers that I went through for my study under the guidance of Dr. Jami Hussain. And let's come to first. The Ministry of New and Renewable Energy (MNRE) adopted the National Wind Solar Hybrid Policy on 14 May 2018. The objective of the policy is to provide a framework for the promotion of a large grid-connected wind solar PV hybrid system for efficient utilization of transmission infrastructure and land. It also aims at reducing the variability in renewable power generation and achieving better grid stability. And we all know a hybrid system is a dynamic system that exhibits both continuous and discrete dynamic behavior, a system that can both flow and jump. Wind and solar sources have vast potential to reduce the dependence on conventional energy sources. However, the stochastic behavior of both these energy resources is a major drawback. As we all know, that wind doesn't always flow, and we don't always receive solar energy, 24 hours a day. But if we merge both of these energies, we can kind of, we can achieve best of both worlds. And the optimal sizing of each component of hybrid system is required to make the system technically as well as economically feasible and efficient. The inputs required for the analysis are solar radiation, wind speed, temperature data, load profile constraints, system control, and economic factors. Solar and wind can be the first option since these resources are available free of cost. Moving to the site that we selected, the site was Pavagada Solar Park, which is in Karnataka. Pavagada Solar Park was conducted in the region in Pavagada Solar Park, covering an area of 53 square kilometers in Pavagada Taluk, Tumkur district, Karnataka. Pavagada Solar Park had a total commissioned capacity of 1400 megawatt by 9th April 2019, out of total 2050 megawatt planned by December 2019. And then another 450 was commissioned by November 2019. As of April 2021, it was the world's third largest photovoltaic solar park after the 2,245 megawatt in Barla Solar Park in Rajasthan and 2,200 megawatt in Huang Hydropower Hainan Solar Park in China. Pavagada was chosen as the site for the project for several reasons. Apart from high solar radiation and availability of land, the region receives very little rainfall. In March 2017, Karnataka Energy Minister D.K. Shivkumar told the Bangalore Mirror that the government was looking to generate wind energy by setting up windmills in Pavagada. Preliminary estimates from the KREDL indicate a potential wind power generation of 250 to 300 megawatt. This is the site that we selected for our study. And the software we used for our simulation was the Helioscope software. And as we can see, we have selected 3 sites going from the left. This is segment 1, then segment 2, and segment 3. As we have excluded the areas of trees and bushes, basically the area prone to shading and obstruction to sunlight. We left the area of shading as placing the modules in the shading region will lead to efficiency loss. After done with the mechanical part, or we can see after the modeling of the solar modules, we perform the simulation and we get the following data, which is that we received the DC power in 3.44 megawatt, and the annual production of the energy was 5.480 gigawatt hour, as well as we can see the monthly production of the power over the span of a year in kilowatt hours. And the plant load factor that we calculated from this data was 18% for solar. We can also see the sources of system losses. There are AC systems, inverters, clipping, wiring mismatch, shading, reflection, soiling, irradiance, temperature, etc. Also, we have here the inverter that we use, the string we use, as well as the count of the inverters and strings and the module that we used for the simulation. We also have the data for field segment 1, 2, and 3 respectively. The ragging we used here was fixed tilt ragging, and orientation was landscape horizontal, as well as the 10-degree tilt and azimuth to be 180 degrees. And the frames in the segment 1 was 6,992, and in field segment 2 was 1,773, and the field segment 3 was 1,979, producing a power of 2.24 megawatt 567.4 kilowatt and 633.3 kilowatt respectively. And now coming to shading part. Now shading analysis is a very crucial step in finalizing panel locations in distributed photovoltaic PV solar installation. The extent of the rooftop area required by a solar PV plant is a factor of panel efficiency and extent of shading. Any kind of shading is detrimental to the performance of the entire solar PV plant. Solar plants are mostly arranged in strings to meet voltage requirements. A shade in one panel not only reduces the efficiency of the panel but cut shorts the supply from the entire string. A shadow falling on a panel blocks the flow of solar energy and eventually the panel gets damaged through heating. We can also see the shading with different angles as southeast angle and southwest angle. And this orange portion which is shown in the figure is the area in which we have not put uh, any solar power plant, any solar panel, because there were bushes and trees in this area which could obstruct the sunlight. So we have excluded this area, and the area which we can, which are in blue, we have put our solar panel on that area, also excluding the areas of trees and bushes. Here we can see the shading by field segments of 1, 2, and 3. Also the solar access by month over the span of one whole year. And solar access weighed by kilowatt peak. Now coming to wind energy. We all know energy generation from wind is the wind power generation means getting the electrical energy by converting wind energy into rotating energy of the blades and converting the rotating energy into electrical energy by the generator. Wind turbines use blades to collect the wind's kinetic energy. Now, wind flows over the blade, creating lift, similar to the effect on airplane winds, which causes the blades to turn. The blades are connected to a drive shaft that turns an electric generator, which generates electricity. The power curve of a wind turbine is a very important aspect in wind energy. It is a graph that indicates how large the electrical power output will be for the turbine at different wind speeds. Here we can see a typical a power curve of a typical wind turbine of 2.7 megawatt, which we have extracted from the internet for our help and for our study. And we have here we have a data for our MERA2 data extracted for this location. And the mean annual wind speed at 50 meter above ground is 6.3 meter per second. Now this is the data which we got, and which its help we extracted the plant load factor to be 38.6% for wind. Now we have a lot greater plant load factor talking in terms of wind as compared to solar. All these data are very helpful for our for our wind power plant. And concluding this, we can see the total power generated from solar and wind hybrid power plant comes out to be 8.84 megawatt, which is 3.44 megawatt from solar and 5.4 megawatt from wind. Total generation in 1 year is 5.480 plus 18.3 gigawatt hours, which is 23.78 gigawatt hours from 8.84 megawatt. Plant load factors we calculated for solar and wind were 18% and 38.6% respectively. And for hybrid, it comes out to be 30.68. Now we can see plant load factor from wind is around 1.9 times of solar. Now this is the reason we have kept more wind capacity than solar capacity. We have taken 2 windmills in wind turbines instead of 1. Thank you, sir. This was my presentation.
Thank you very much. Thank you very much. Well,
thank you, sir.
It was nice to listen to you. Are there any questions? We don't have any questions in chat. So thank you very much, Ruba.
Thank you, sir.
We wish you success in your future studies.
Thank you so much, sir.
Now I would like to ask the host whether we are ready with the. Yes, now we have. Okay, so let's start to see the video. This is from Ray Messi from Entura. Could you share it again? Okay, very good. So do we have The person who will present it. From Hydro Tasmania, maybe Peter Ray, are you going to present? Yes, welcome. Nice to see you, Peter.
Thank you.
Please, the floor is yours.
I'm not sure about what's happened to the voiceover. The material was forwarded, but I understood there was to be a voice as well.
There is no voice at this moment. Maybe you can just go through it from Hydro Tasmania and Tura and Momentum Energy. This is.
Well, Hydro Tasmania is Australia's largest renewable energy generator, and it has for more than a century been generating electricity from hydropower, but has moved on to now developing in the 1990s, and since some 300 megawatts of wind owned by or part owned by Hydro Tasmania, and quite a bit also developed by other owners, so that there is a significant amount of wind generation. And if I hesitate a little, sorry, but I'll just have to read this and talk to it. There's a growing gas and electricity retailer dedicated to making energy simple for customers. That's something which has been subject to some debate as to the extent to which gas should be continued to be operating any electricity generation in Tasmania. And Tura is the division of Hydro Tasmania, which is the engineering consultancy, and Ray Massey is one of its leading specialists. It has been more than 100 years of creating energy and maintaining hydro, wind, thermal, hydropower and water assets. It has a branch operation in Delhi, and I've visited that on several occasions and found that they were a very well qualified group of people, and that's something which I hope will continue and grow. It has over 230 staff. It's headquartered just near Hobart, just in a suburban area of Hobart. It has all of those specialties. It's a very significant group of experts have been put together. It came about when Hydro Tasmania was reorganising from having a transmission and a distribution operation, which they were then separated and were set up as separate companies, and Hydro Tasmania took over a number of the specialists, and it formed the specialist group, which had formed it as Tura, and that's been at times operating in a very large number of countries around the world. The last time I checked, I was told there were 21, but what it is at the moment, I'm not sure. I know that some of the work that they've done in some of the countries of the world, it's certainly an operation which has done a lot to change, and we can have a look at some of those. Agnew Gold Mine, the integration, design, hybrid control, supply and commission. Antarctica, designing and advising on hybrids. Cooper Pedy, Rottnest Island, King Island. King Island is one in particular, King and Flinders Islands. There are islands north of Tasmania, between Tasmania and the major part of Australia. Incidentally, for anybody who doesn't realise, that very small area down at the below the mainland of Australia, Australia to put it in European terms, would stretch from Madrid to Moscow. It's a very large continent. Tasmania is bigger than Ireland, the country Ireland. It's bigger than Belgium and Netherlands put together. It's not a tiny, small as it appears. Flinders Island and King Island are between the major part of Australia and Tasmania, and a lot of work has been done on those islands to design remote area power supplies, and King Island is also at the moment the headquarters for an offshore wave energy latest design, which seems to be delivering quite well from what I'm told. Flinders Island recently had developed there a new style of remote area power supply generation. Flinders has, as does King, some solar power, but also a design for remote area which is quite remarkable. And I won't attempt to describe it because it would take me a little while, because I don't know it well enough to be able to say it in a few words. Indonesia and the Pacific and Papua New Guinea, places where Hydro Tasmania and its company Entura have been operating. Entura has been an organisation and continues to be one which operates in various parts of the world with off-grid, in particular as a specialty, and they've done work which has provided significant growth. You can see on the scale that's in front of you that growth which has taken place. I recall when we first started to branch out across the world with consultancies, that there were some very big ones and some very interesting ones, and some done in conjunction with other engineering companies from other countries, including an arrangement that we had with France. The figures that you can see there has shown the growth. If we could have the next slide. You can see that slide, but if we could have the next one, we could go on.
Dear the host, would you please go to the next slide? Dear host. Dear host, are you there?
It certainly shows the off-grid hybrid trends and how those hybrid developments, which Entura specialises in, have grown so significantly in recent years and are planned to grow very significantly in the not too distant future. We seem to be jammed on that one, and I don't know why the person in charge is not able. Perhaps Tana, you could ask again if they could change the.
I will just try to call them. Sorry.
Just to explain a little while that's happening.
I
was the chairman of Hydro Tasmania for 11 years, from 1993 to 2004, and then I did some consultancy work following that time. It's been one of the joys of my life to have been associated with this company. It's been one of the privileges that it is able to operate with a history which goes back for more than 100 years, and with a tremendous build-up of expertise from all of the experience over those years. Off-grid hybrid trends in the various states, the number of projects by state, and they're shown how it's grown since 2011 with a very small total through to the current time when it has more than or just on 20 projects by the state, including, and then there's a whole list of those. Entura has been involved very widely in the development of off-grid hybrid to systems for various, particularly remote area power supplies, mining areas and other areas away from the distribution systems of Australia, the Australian continent, which of course, as I mentioned earlier, is a very large continent. Off-grid hybrid drivers in the mining sector, the mining sector has become much more conscious of the need to try to comply with what's being now universally accepted, which is that we must reduce carbon. And there are many mining companies which are taking strong measures in relation to that and using Entura's skills to assist them. Fortescue is a particular company which has developed a very strong lead into how to replace carbon-causing forms of generation and replacing with renewable energy. And Fortescue is also now developing in relation to hydrogen generation, and I would hope that Entura will be able to play a part in the development in Tasmania of the hydrogen generation, which Fortescue is developing. It's also developing hydrogen in Queensland and other places, a number of places in Australia. So that's happening. Glencore, which is a mining company, has set an aspiration to reach net zero emissions by 2050 for emissions from downstream use of their products. And that's an interesting development. The electrification state of play, mine electrification is a foundation enabler for the clean energy transformation of mine sites, and some of the energy, the executives of the mining industry who were surveyed have given results which are set out on that slide. And it indicates that the mining sector of Australia, which is a very important part of the economy, is moving significantly to achieve clean operations. And so there will be lots of work opportunities for the off-grid renewable energy developers, hybrid developers, to be able to operate in that sector. And again, I would expect that Entura will be able to do a lot of that work. Perhaps if we can move on to the next one.
Next slide, please.
This is an unexpected opportunity, as far as I'm concerned, to talk about a subject which intrigues me, but which I wasn't intending to or expecting to have any role in talking about. So please excuse me if I'm not dealing with them in a learned way, because I've never seen the presentation before. Let's look at the bottom line from the operations, and that I think sets out demonstration-based projects and grants, the private sector, commercial interest, larger infrastructure and large projects, all of them showing developments, rapid development growth in the Australian mining sector. And that quote at the bottom, I think, probably says it all. Renewables are a no-brainer for the Australian mining sector. And it's very encouraging to see the responsibility being accepted by the mining sector, as well as by a large number of the other forms of generation for electricity supply. We've got the coal and gas generators to a large extent planning their transfer to renewable energy growth. And we can then see on the next slide where we're going from here. Certainly there's grants available and assisting in some of the developments which are taking place, but basically private sector investment with people like Twiggy Forrest from Fortescue leading the way, I think it'd be fair to say, in the development of alternative hybrid schemes rather than the polluting schemes. Let's have a quick look at this. The new player knowledge gap, mining industry earlier on the learning curve compared to power utilities, but with arguably a smaller risk appetite. Increasing number of IPP and financier parties without necessarily runs on the board. Supplier interest increasing, but without the experience, full integration and understanding. All good for competition, but different levels of knowledge. Traps still for new and existing players contractually and technically, particularly with multiple counterparties. Technical challenges, still the gas engine response times and the operational levels differing to diesel, maximum efficiency versus minimal fuel use. Multiple suppliers not familiar with hybrid integration challenges, technical as well as contractual gaps. Operational experience predominantly in traditional thermal plant only across the country. Now multiple elements. Projects are still largely case by case. The key integration is what Massey is suggesting, and there are probably few people with a better understanding of what's happening in this field than Ray Massey. So I think we can take what he's saying as being a very objective assessment of the situation and what is required. He says need overarching view by hybrid system approach. Individual suppliers won't necessarily have that overarching view. Early intervention and understand what's coming. Early integration view, planning right through to operations can help bring understanding of operations and outcomes. And those are the summaries from a person who has a very wide knowledge of the situation.
The key to it all is really integration. So taking very much an integrator's approach to looking at every piece of the puzzle, be that contractually, technically, and really.
Dear host, what's happening?
We've now got Ray Massey's own voice, so I'll drop out and listen to somebody who is the real authority.
Okay. So, it continues. Dear host. We've lost him again, have we? Okay. Well, the technology mixed integration, renewable energy can provide a cheaper real power. Not all of the system reliability requirements alone. Hybrids rely on careful integration of renewable energy through automated control and enabling technologies. Automated control, speed of response, or ability to deal with system complexity, varying system and element states, future changes, and operator experience. Enabling technologies support renewable energy, maintain system stability, security, and safety, managed through control. This is years of experience with particularly King Island, going back to the 20 or more years of development there of these remote area power supplies.
Spend on technology versus level of acceptable risks needs to be understood early on in the project. Available renewable energy resource understood and the economic impact of that. Optimisation through modelling energy economic power systems. Legacy system integration more challenging and needs careful consideration. And coordinated collaboration can help significantly. That is the customer. OEM involvement, critical designer, and OE and IPP are all involved in the development of the hybrid systems. Just referring while we get the next slide up, King Island started with battery and small wind and solar, and has now developed to a number of other means of storing power. It has reached the stage of a combination of various forms of generation and distribution to the stage where it supplies the largest part of what's required for farming and for the various industries on the island, which is an island with a population of, I'm not sure, but something between 2,000 and 3,000 people. I think probably still. Can we change the slide? Some key integration lessons. Earlier focus on ongoing operation is critical, include operator experience and contractually. Test off-site and plan for minimum site time. Knowledge of suppliers and customers is still growing and allow time for development. Customer understand the need and get specification and contract right. Supplier must understand the complexity for hybrid needs. Prices decreasing, functionality increasing. Nothing's truly standard yet. Supply chains and delivery models are still evolving, and you can expect change. And I think I recognise some of this. The vanadium redox battery was the early one used in King Island, which then moved to advanced lead acid and then to the lithium titanate. And they've been developing regularly at the time when I was involved, both as the chairman of Hydro Tasmania and as the chairman of the Tasmanian Renewable Energy Development Board. We were doing a lot of work in encouraging the research and development work being done at King Island and then subsequently on Flinders Island, and had the recommendation made by that board to for the grant of further funding, which was obtained to take forward more rapidly the experiments that were being undertaken. And I think one of the important things is that under the present government, there should be further funding made available for further development in the research area. And when Ray Massey says expect change, I think that's probably a good way of looking at the future. But it's quite different to the normal way in which you go about providing electricity supply to people, but it's a way which can ensure that remote areas, both in Australia and elsewhere, are able to obtain electricity on a basis which does not create the problems of carbon, with which we're all becoming more and more familiar as to what the problems are. I wonder, can we change? The vanadium redox wasn't as permanently successful as it might have been, and the further developments have improved. A bit of trial and error is necessary in all of these sorts of developments. That apparently is the conclusion of Ray Massey's presentation. I'm sorry that I was the one who was talking to it rather than Ray himself. I don't know what's happened to his voice background, but he's certainly somebody who has done a massive job in the development and the understanding of these various challenges which have come from around Australia and around the world to provide clean energy to remote areas using hybrid means. And I hope people who are hearing this and looking at the screen are able to think a little further about this and to make some inquiries and perhaps even contact Entura if they'd like further information. It's Entura's based at a place called Cambridge in Tasmania, and I'm sure that they'd be keen to respond to anybody who expresses interest in knowing further about their operations and how they could benefit any of the areas which are challenged by remoteness. So thank you very much. Tane, I'll hand back to you. It's
Thank you. Thank you,
I
Peter. It was a very nice overall view of the activities. And now we have, thank you, Peter. It looks as if there are no questions for you. And now I'm looking to the program. I have in the program, I see, oops, sorry. I'm looking at the program. And program, there's after Ray Messi and Tura, we have Rahul Walawalkar. As far as I see, he is not over here. The webcon, the host, would you please try to reach this person? He is not, or she is not here. And Mohammed Ansari from Ireland, India. He is not also part of the speakers now over here. So the third person is Syed Raat Ara and Jamia from Jamia Millia Islamia. Again, we don't have this friend, Syed Raat Ara. And then we are looking for tractable engineering. Santosh Kumar also is not here. So we only have Q&A. This is no, this is not. So I think we don't have speakers. They didn't attend here. As far as I see, they are not in the room. Do we have an explanation for this, dear host, webcon? Webcon? Dear host?
Yeah, yes, sir.
Do we
Rahul
have
Kumar.
any explanation on this? Some people are missing over here.
Yes, instead of Mr. Rahul, Bindu will able to join, but he has not joined yet.
Okay.
Yeah, I can see. Then, sir,
I mean, we can wait about give 5 minutes break, and then try to reach these persons.
yes, sir.
Or if they are not coming, then you inform us. We end
Okay,
up
sir.
the session.
Okay,
Otherwise, I mean, it is up to you to contact those people and ask if they want to make their presentations.
sure, sir.
Send an email to them. They should say at least we don't make, so we don't wait for them. You have the contact of these people. Okay, I give about 5 minutes break in this session, and the host will try to reach those people. Maybe they are trying to reach here due to time difference or something. Let's give five minutes break. Now it's 14:58. in my country, it's also over there is 18, 2.5 hours. In India. So let me give 5 minutes break, then we'll make another decision. So in 3 minutes we will decide what to do. But at this moment, Tuba, Fatima, do you have anything, any comment, any questions, anything to raise? You can raise it in these 3 or 5 minutes. Peter, you are here. Maybe you'd like to add something, and let's hear Tuba, whether she needs to know something. He needs to know something about experience Peter Ray, something from me and from Stefan.
Make me happy to talk.
It
Yes.
was a wonderful experience being with all these senior people, all of you. It was an honor to be in this
Our
conference.
pleasure also. Young people, you need to take over. It's your time. This European Green Deal is coming, and global transition is coming, International Renewable Energy Agency. So now you are 20, 30, whatever. In 2050, you will be 50 years. It concerns yourself, your children, grandchildren. You need to take over this responsibility. So far, so good. We made something, but it's your problem.
Yes.
Do you have any questions?
No, sir. No, thank you, sir.
Okay. Any comments? Okay.
Yes, sir. Thank you, sir.
Oh, thank you. Thank you for your involvement and efforts. Dear Peter, I think the other speakers are not here, so I will close the session. If you have any other comments, please, Peter.
Yes, well, I'd just like to finish the session by saying that I think one of the very important things is what's just been said, and that is that the youth of today prepare for the challenges of tomorrow, and those challenges are going to be significant. But what we've got is the opportunity to see that technology and current development has been able to make space tourism a reality. And if you think of how unlikely it was that we'd have space tourism when you think back a few years, it is an indication of the way in which technology is providing. And I think that the opportunities are changing at such a rapid rate that we'll find that by 2050, the means of providing renewable energy will be quite different to those which are prior today. And I think that one of the important things that I find extremely interesting is the way in which the Energy Globe Awards, and I'm one of the jury, the international jury, which selects the awardees, the number of young people who are presenting proposals for new ways of dealing with things gives me great confidence that people are rising to the challenge, that young people in particular recognise that it's really up to them as to whether we go on from where we are to where we need to be by 2050. And if you look at the Energy Globe entries, there are an extreme number of ways which are presented there which can help sustainability. And sustainability is what we're all about. Climate change is one of the aspects of the challenge, but there are many others to achieve sustainability, and that's what we must achieve. And so one of the things which is an important part of the whole achievement of sustainability is the provision of remote area power supplies. utilising at the moment the hybrid systems about which Ray Massey's paper was directed attention. And so whilst Ray wasn't for some reason able to be heard, I hope that by talking about it, I was able to help people a little. I do apologise that I've never seen the presentation before, and it was a bit challenging to try to talk to it, but there are so many things that we can talk about that are important. Let me just say, may technology continue at a rapid rate, and may we find that the things such as the things Ray Massey was talking about will come to reality sooner and better than we could hope for, and that we do find that by 2050 we'll have mastered all of the aspects which involve renewable energy and the other components of sustainability. So thank you for the opportunity to just say a few words there. It's something for which I continue to take a very strong interest, and I hope that I'll be able to see further developments taking place. So thank you, Tane, for chairing the meeting. I'm sorry that we're a bit short of numbers, but fairly well, and I hope that we catch up before too long and that we finally master the COVID virus to the extent that travel becomes possible again. So thank you very much.
You. And maybe I should a little bit mention what I am doing now in Eastern Black Sea. 2 cities, all the local governments and mayors and universities and all the consumer organizations, environmental organizations, industry chambers, chamber of engineers. Tomorrow we meet to talk about the transition of those 2 cities, Ordu and Giresun, to 100% renewable energy. And that's we are just going to, with Professor Hasan Heperkan, who is an expert in energy efficiency, and we will present this. Then we will try to show the mayors that it's their duty to bring together all the stakeholders in line with European Green Deal, because Turkey is a candidate of Europe, and together with those people, for the people, with the people, how to transmit this transition, realize this transition in Turkish cities. So this will be a real experience tomorrow for us. It will be the first such a meeting in Turkey. And so now not only the technologies, but disseminating this information, the solution to the people, which is a requirement when you use renewable energy with high entropy, distributed nature to produce your energy carriers in the point where you consume. So this systematic evaluation is needed to match with the realities of the nature, human activities. So this is another practice we need to go further, and it will be a teamwork with participation of all stakeholders. Thank you very much, Peter. Thank you very much, Tuba, Fatima. Thank you, Stefan, for your efforts to organize all this conference and other people who contributed. I end the session over here and give the word to our General Secretary, Stefan Zenger. Thank you. Thank you very much.
Oh, that is an unexpected honor. Thank you very much, Tanay, for running this session well.